Hey there, welcome to my YouTube channel. If you have watched any videos on this channel before, this is me saying thank you for coming back. And if you are a first-time viewer, I'll say welcome once again, and please remember to subscribe and click the notification bell to get notified when new videos are posted. Today, we are diving into Pandas with a beginner-friendly lesson. If you know a bit of Python but haven't used Pandas before, you are in the right place. And if you are not new to Pandas, this video will help solidify your understanding of the fundamentals. So, you are still in the right place. This lesson is split into two parts. In part 1, we'll use a practice dataset to learn the basics of Pandas. Then, in part 2, we'll step up our game by working with a real dataset to answer questions and make sense of data. By the end of this, you should be ready to tackle your own data project with a better understanding. Let's get started. So, what is Pandas? Pandas is a popular open source data manipulation and analysis library for Python. It provides easy to use data structures such as data frame and series and several functions designed to simplify working with structured data. So let's go into Pandas. So I'm using Google Colab. So most of the libraries I need, for example, Pandas, and we're going to be using NumPy. They are already pre-installed and they are already pre-installed into Google Colab. So that's how we are going to begin. So the first thing is to import your library. So I think I should comment it somewhere and say import libraries. I'll just put it there. Then I'll say import Pandas as PD. And we're going to need NumPy, but NumPy is not the focus of this lesson. We'll just need NumPy to generate our data and to do some other little things in the whole process. So I'm going to import NumPy as NP. NumPy as NP. You could import this as anything. You can import Pandas as AD, but I mean, best practices is just easy to use as PD. So I'm going to load my library. So because I'm using Google Colab, it's going to connect. It's going to connect, and that's it, connected. So I'll go into a new cell, and the first thing is for us to create a series. You know, in Pandas, we have data frame and we have the series. So when we talk about a series, it's just what you call like a one-dimensional array. So I'm going to do it this way. Let me just say creating a series. Then I'll call it PD series equals to create a series. You use pd.series, where this PD is coming from, because I imported Pandas as PD. So if I imported Pandas as AD, this is going to be AD. All right. So yeah, that's it. So let me leave it as PD and say pd.series, and I'll create some just random numbers. So I think I'm going to use 2, 10, I'll use 8, I'll use 7, I use 3. Okay, what else can I use? I use 5, I use 15, 95. And I think we should add a missing number, and this is where the NumPy comes in. And I'll say np.nan, and just add some other numbers as much as possible, then 40 and 3, and that's it. So let's run our code. Okay, we could see it's saying Pandas has no attribute called series. So what could be wrong? It is from the spelling. So we're going to say series in capital letter. So don't be afraid. It is normal to get errors when you work with your codes. So, and you just read it and you could correct it. So here now, by looking at this, I could see that it is a spelling error. And let's run it again, and it should work now. So we have it. Let's check our series and just run it and say PD series to view what is inside. And you can see we have this. You can see everything. It has just one column, and that is how we have a series. But when we talk about a data frame, it is usually two-dimensional. Usually it has a row and it has a column. That is why when we explained pandas the other time, we said it helps to deal with structured data. So let's create a data frame. So we're going to generate, like I said, we're going to be using like practice data set, that it is not a real data set. So we just generate it randomly. So here, let me put a comment and say create a data frame, and I'll just say PD underscore data frame equals PD dot data frame. Mind the spelling, so you can see data with capital D, then frame. I mean, if you don't do it right, you're going to get an error, and you look at it again, and that's it. So here I'm going to use create a dictionary so that I can use it to create my data. And when you talk about dictionary from Python, it talks about like key value pairs, so we can use it to create a data frame. So I'm going to use my braces, and here I'm going to name it, let's just say colon 1, and in column 1 I'm going to pass in values. I can say 4.0, then a comma, and I'm going to have colon 2, and I'll say PD. I want it to be a time. So in pandas we have different functions that you can use. Here I'm going to use a timestamp because I want to generate like a date for my data set. So I'll say timestamp, and I'm going to pass in the date. So let me pass in today's date. So the year is 2024. I'll pass January, and I'll pass January 8, and that's that. And we come again, and colon 3, and in colon 3 I want to use a series in colon 3. So like we used a series the other time, and I'll say pandas.series, and I'll pass in 2 with the index. That is, I want to pass in 2 into the data set, and I will say lists what I want to do in a range of 10. That is, I want to generate 10 values of 2. Now coming back, I want to specify the type. I want to use a float, so I use the type equals float 32, float 32. Right, and that's that. Then I'll create my colon 4. I will use a numpy, create it from a numpy array. So I will say np dot array open bracket. Then I want to generate, of course, 5 over here, and I want to generate it multiplied by 10. Okay, so I'm gonna say multiplied by 10. That is, should give me in 10 places. All right, then I'll say d type. Here I want it to be an integer, so I'll say int 32, int 32. So, and the next column, I'm creating 6 columns, so I'll say column 5, and here I want to create like categorical data. So here you can use pd.categorical. It is also a function in pandas to create categorical variables or categorical columns. So I'll do this, and I'll pass the category. So the category I want to use is up and down, up and down. So I'm going to pass up 5 times and down 5 times. So, but I'm going to pass them in form of up, down, up, down. So I'll do this and say down, then I'll highlight it so I don't have to do it over and over again. Then let me put a comma here, then I just copy it 5 times to make things easy. So here I'll say 2, 3, 4, 5. Then I clear the last comma. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So why am I doing this? The data I'm generating, I want it to have 10 rows and 6 columns. Then here I'm going to say colon 6, and I just want to pass in cats. I mean, this is just a random data which makes no sense. All right, this is just a random data which makes not a single sense. So I'll just pass in cat into it, and that's it. So let's try to generate our data from here. Okay, I'm seeing an error. I don't know where that is coming from, so let's do something here. Where is the error coming from? To be sure about that, let's run it and see if any error. So you can see here it's saying we forgot a comma. Okay, perhaps you forgot a comma, so it is over here because there's a comma that needs to separate this from this. So here now you can see I've created it. So let's view our data frame. Then pd.data frame. So look at our data. So we have column 1 is just 4.0 that is there, so everything 4. Here column 2 generated the same date, column 3 2, column 4 5, then categories, then column 6 cat. So this is just a practice data set, which makes no sense, of course, but we're just using it to learn the basics. Now, what is the first thing we're going to be learning in Pandas after creating our data frame? So we've been able to create a series over here, and here now we've created a data frame. Now the next thing is going to be to check the data types. Let's say you want to check data types in Pandas. That is the data types of each of the column that you have in Pandas. So you say check data types. Then I'm going to paste the data frame. Then you use this. It is called dtypes. It's one of the Pandas. I wouldn't call it a function. It's an attribute of Pandas because you're using to check the attribute of the data. So don't make a mistake of like passing this to it. You see, it's not going to run. If I put this, you can see I can't use that. So I need to clear it and say dtypes. So it will tell me the data type of each of my column. From column 1, we have float, date time, float 32, integer. This one is a category, and the last one is an object. Okay, and that's it. So how do you view your data? If you don't want to view the whole data, so let's say you have like a large amount of data, normally only part of it will show, of course, except you do some settings where the whole thing you want it to show. But in this case, you want to show the top part of your data, so you can show the top part, and you can also show the down part of the data, or what you call the top, you call it the head, and you call the down part, you call it the tail. So just that, bear it in mind, and that is how you do it. So that's what we're going to do over here, and we just say to check it, we say our data frame, and we say .head. So in this case, it is not an attribute, it is a function. So you need to have those brackets over there, and you do that, and that is it. So it will show you the first 5 rows by default. So if you want to see more, think you can pass. Let's say you want to see 8, then it will show you the first 8 rows. So the number of what you want to see, you can pass it into it. You can see. So that's it. Then let's move to seeing how we can see the tail. So just bear it in mind, it's going to show us everything that is below the last part of the data set. The last set of rows we show. So we say tail, and that's it, and we'll check tail. So it's going to show us the last 5 rows in the data set, and you can also check maybe the last 2, and that's it. So that's how you do view your data. So the next thing we want to do is you want to check the indexes in your data. So you want to know what is in the index. You want it to bring out the index for you. So I use my data frame, and I will just say .index. So this also is not a function, it is an attribute. So you can see if I use this, it is not going to give me anything. It's not going to be callable, but if I clear it, it's going to be callable. So I do this mistake a lot while getting started with my data science career. Whenever I want to use some things, I just assume everything is a function and I just add this to call it, but it is not like that. So, and what is the difference here is that This is giving us like an attribute of the data. It's telling us the attribute of the data frame. It's a pandas attribute showing us that. But when you talk about a function is doing a specific task. Okay, that is when we use .add, we are saying a specific task. Show us a specific part of this data. But when we use things like index, for example, we are trying to get an attribute of the data. That is why it is not like a function like other ones. All right. So the next thing we're doing is we want to check, when you look at your data set, there's a need for you to know about the data. What is really happening in the data set? Okay, so to do that, just like the way if you want to know about someone, you will say describe yourself. The same way, that is how this function to know about the data, that is how you use it also. So you do this and just say pd our data frame and just say .describe. That is describe this data, and that's it. Describe, and this is what you get. So you see now in the description of the data, it showed us the count of column 1, column 3, column 4. And why is it only showing us column 1, column 3, column 4? Now, this is the reason. It is because those are the parts where we have numeric data, where we have either float or integer. Those are the places where we have numeric data. So it's telling us the count of the row, the mean, the standard deviation, the minimum values that we have there, 25%, in terms of the division of what we call the quartiles. So the 25%, the 58%, the 75% of the data. Now, in this case now, we are having 0 as the standard deviation. And why? It is because in our data set, we have like the same value over, so it couldn't like record any standard deviation or thereabout. So we don't really care so much because we are not really focusing on the statistics in this video. Okay, so that is that for now. Now, there are things that happen that you want to change the orientation of your data. You want to change the orientation of your data. So if you look at the shape of our data frame in the moment, you will see this. If we say this data frame and we say .shape, in .shape it is also an attribute. You can see it is 10 by 6. That is 10 by 6 means we have 10 rows and 6 columns. So the first thing is usually the row, and the second part is usually the column. So in this case, what if you want to like reshape your data? Okay, you want to what we call transpose. You want to do that so that everything in your row will become the column and your column will become the row. So to achieve that, we're going to be doing this, and it is very simple. It is transpose, and we use the same, like the first letter in transpose to achieve that. So we just say our data frame .t and we run it. So you see, that's what we have. That's our data frame. So you can see it is transposed. So in this case now, it is not 10 by 6. It is not 10 by 6. It is now 6 by 10. That is, it is now 6 rows, 1, 2, 3, 4, 5, 6, and 10 columns. From 0 to 9, of course. So that would be 10. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's now 6 by 10. So we've been able to transpose it. So there may be a need, maybe you want to do some analysis, and the library you want to use may say, oh, this is the way the data should be organized. This is the way the data should be structured. So in those scenarios, you need to transpose the data to meet a specific objective that you are trying to achieve. And that's it. So nothing is written on stone. It just depends on the task at hand that will determine what you do to move on with it. So that's it. So what is the next thing we are going to be learning today? It is very simple. We're going to be learning another simple thing in Pandas as you get your hand on Pandas and you explore your data. So the next thing is sorting. To sort your data set. How do you sort your data set? So there are some times that you want to sort your data set. Maybe you want to sort the index, based on the index. You want the values maybe that are the higher value to come first and to the lower value in ascending or descending order, whatever way that you want to do it, you can achieve that also. So I'll call this sorting. I'll call it sorting. And to do that, we use, so whenever you want to do something in Pandas, you want to do something to your data frame, so you can use the name of the data frame itself, then just add dot, and you can pass in the function that you want to use. So in this case, we use sort index. Sort index. But one of the things is, if I just say sort index, you're going to see it is not going to work as I desire it. It is not going to work the way I desire it. It is not going to work the way I desire it, because I'm just saying sort index. But I need to add other specifications. I need to add other specifications. For example, what direction do I want to sort the index? Even when I'm sorting it, what axis am I sorting from? So I can do this and say, I pass in the axis and I say axis equals 1. Now, when I say axis equals 1, I'm saying sort by the column and not by the row. So I'm telling it to sort like from up down this way, sort by the column, not by the row. Okay, so that is axis 1. If I want to sort by the row, I will say 0. So I'm sorting on axis 1. Then I'm going to say ascending. I say equals true. Ascending equals true. So when I do this, let's see what we have. Now you can see the data is still like the way it was. So you can see 0 to 9. Now if I say ascending equals false, let's see what happens. So when I say ascending equals false, based on the index, it is supposed to show me the descending part. And yeah, so that's it. Sorry, I was supposed to sort by the row rather. It's supposed to be 0. It is supposed to be 0, not 1. That was why it wasn't working. So when I say ascending equals false, this is from 9 to 0. This from 9 to 0, you can see everything like the last part of the data coming up, that's descending. So when you say ascending equals false, what you are trying to say is descend, show it in descending order. And if I change this to true, if I say change this to true, you can see everything returns back to like normal. So that is how you sort based on the index. Now, if you are not sorting based on the index and you want to sort based on the values that you have in the data frame, that is, you want to sort based on a specific column that is not the index, how do you achieve that? So you use another pandas function, or people call it like, you could call it like pandas method, say the data frame. So instead of using sort index, here I want to sort it based on the values that I have in the data frame. And the values, how do I specify that? That will be the column containing those values. So I will say sort underscore values. Sort underscore values. Now, what do I want to sort it based on? What do I want to sort it based on? Do I want to sort it based on column 1, column 2, column 3, column 5? Or which column do I want to sort it on? So here now, let me say I want to sort by column 5. Or based on column 5, I will just specify the column name and say column 5, and I'll run that. Now, if you look at it in column 5, you will see that it is sorted by default. When you sort, the default is in ascending order. When you sort, the default is in ascending order. So you will see that you have D that is down before U. So if you read the alphabet, you have A, B, C, D like that up to U. So the D will come first before the U. So let's say I want up to be what will be above, and of course down should be down. So how do I achieve that? I just specify the same thing we did the other time, and I will say ascending equals false. Then it should show me in descending order. So you can see now we have up, that is U is coming before D. So that is how you sort your values in your data frame. you sort your values in your data frame. So we've been able to cover some basics of exploring your data in Pandas, from the shape to sorting to creating the data frame to creating series and some other things. So now we are moving into like, how do I select data? How do I select a specific data from my data set? And that is really very important, because as a data analyst, a data scientist, or someone who is not even in a data career, but you need to use Pandas to achieve a specific data related task, you will need to probably filter, pick a specific part of the data, drop some part of the data set. You're going to have to do several things around selection. So you can't, run away from it. So let us check some basic selections in Pandas, using Pandas. So let's just call this part selection. We call it selection. And what are we doing? We could say the data frame, and here now to select. When you call the data frame, because I already, moved forward a bit, so let me just move backwards. To select, you're going to use like the way you write your normal array in Python. So we use this, and all you just need to do to select a specific column in Pandas is just to pass in the column, and you select that column, and that's it. Let's say column 2. And you see column 2, this is it, column 2. But this is not the only way to select data in Pandas. Okay, to select data in Pandas, so we can use another form to select. We could also select based on using like the number of in relation to, how do I put it now? We can also select our data set based on the rows. We can select our data set based on the rows. So we can specify like the number of the row, or I would say the index from where we want to select the data from. So we can use that also. So if we want to select, like, let's say we want to select the first 6 rows, we can do that by using this. So we use this and say 0 to, that would be to 6. We want to select from 0 to 6. So starting from 0. Now, when you're trying to do this kind of selection, the 6th, like the number 6, the one falling in number 6, because remember, your count in Python will start from 0. So if you are going to have like 5 rows, it's going to be 0 up to 5. It's not going to add 6 to it. But if I want to select 0 to 4, I will say to 5. But if I want to select 0 to 5, I will say to 6. And that's it. So let's see. And here we have it. Column 1, column 2, column 3. All the columns, we're going to have them. And we're going to have the first 6 rows. That's 1, 2, 3, 4, 5, 6. And that is how you do that kind of selection in Pandas. And what if you want to select multiple columns? Let's say the analysis I want to do, I only need 2 columns to do them. So what you do is you just use your data frame again, put in the necessary braces that is required, and what do? You pass in the name of the columns. Now, this is the mistake that we could make. Because we pass in 1 column the other time, let's say I'm trying to select column 2. It worked while I was selecting just 1 column. So let's see if I add another column, if it's going to work. Let's say I want to select column 5 with it and pass it. Do you see? It returns an error. And you can see it's returning a key error. So it means something is wrong with my selection process, because it's a key error. Here is not a type error. This is not the video where we explain different kind of error. So there's something I'm doing wrong within my data set. There's something I'm doing wrong within my, within my code, the code used to select my data. Now, when you are using multiple values within an array, okay, when you pass them within an array, they need to be to have their own curly braces. Immediately there are more than one. They need to have their own curly braces, defining that this is a list. Okay, I'll call it a list, like this is a list. So this curly braces that we have here is the selection curly braces in itself. so it doesn't deal with the list we are passing into it. So for me to select more than one, I will need to pass in a list and not just like having it as a single value within it. So I'm going to pass it as a list. And how do I pass it as a list? It's just to wrap this into a list of its own, and that's it. So you can see it is a list of its own that I'm passing into it. Why? Because this PD, this our data frame selection, can only receive like one input. So if I want to select more than one column, I need to pass it in as a list and not just as individual values in themselves. So now let's see, it's going to work. Do you see? And that's it. That is how it is done. So there are other ways to select. So there are scenarios where you want to select, let's say, a part of the column or a part of the row. I want to select a part of the column or a part of the row. Okay, how do you do that? That is what we are doing next. Then here I'll call it like selection by label. Selection by label. So here we're going to be using a function called lock. We call it lock. And what are we doing with lock is that in lock we can pass in what are the rows we want to select and what are the columns we want to select. And first, let's assume that I want to select all the rows, but I want to select specific columns. I'm going to do that and pass in the specific columns that I want to do. So the first part before the comma is going to be my row. Then the other part after the comma is going to be my column. So I'm going to pass in the columns I want to select in this case. So let's say I want to select column 1 and column 3. Remember why I am passing it in as a list, just like the way we did it the other time. You can see this is a list that I'm passing into it. You can see it's a list, just like what we did here that we passed in a list, because we can only have one value before the comma and after the comma that needs to be bounded together. So we only pass it as a list. Now let's run it. You can see we have column 1 and 3, and in column 1 and 3 we have all the rows they are showing. We have all the rows showing. Now we can also do it in another form. So let's assume that we have multiple columns, like we have like, let's say 50 columns. I want to select like the first 30 columns. How do we do it? Do we need to write like column 1, column 2, column 3, column 4, column 5 up to 30? That's going to, a bit awkward, since it is like, it is sequential. The selection of what we need, they all follow each other, like 1, 2, 3 and all. So in that case, we can try another method, still using lock. So we use .lock. Then we have it this way. You remember the row will stand as the first part. We can also use this. So if I use this, it's going to give me all the rows and all the columns. So you see, it's going to give me all the rows and all the columns. So if I want to select a specific part of the column, I can just say, pass it in and say column, that is the first column. Let's say I want to get it up to from column 1 to column 4. I'm just going to say column 1 to column 4. Column 1 to column 4. And when I do that, you see, only column 1 to column 4. So if it is up to column 30, I can just pass in the name of the last column. It's going to give me everything up to that point. And that is how this works. Now, what if I want to select just some part of the row? Just some part of the row, even while selecting like specific part of the column. Now I will say put in my data frame, and I will use also .lock and do this. Remember, the first part is the row and the second part is the column. So I want to select column 1 to 5. I'll say column 1 to column 5. Then here I only want like the I want to pass the index of the row. I need it from just, let's say I want to get 0 to 4. I'll just say 0 to 4, and that's it. You can see I have 0 to 4, that is the first 5, giving me only the first 5 column. And if I say to 3, it's going to give me that at the same time, and that's it. So what is the next thing we need to do? Let's say we want to select just one value. Let's say we want to select just one value from our data frame. We want to select just one value from our data frame. How do we do that? So let's load our data frame again. Let's see and look at something we want to select. Let's say I want to select, since they are the same, but let's say I want to select the 4.0, that is the first one. Let's say I just want to select this single value over here. So it is in column 1 and row 0. Column 1, row 0. How do I pass it in? Very simple. Remember, before the comma and after the comma. Before the comma, that is the first part of it, is the row, and the second part is the column. So I want to pick something from row 0, so I'll pass 0, and I want it in column 1, so I will say column 1. Oh, it's a string, so I need to pass it this way and say column 1. So let's see. That did not work. Why did it not work? Why did it not work? Okay, you can see key error. So I made a mistake over here. I didn't use my .log. So you can see 4.0, and that's it. 4.0. Let's do one more. Let's try to pick something else. Let's try to pick something else. Let's say I want to pick the down that we have here. So the down here is going to be in column 5. Is in column 5 and is in row 9. So to do that, I'll use the same .log that I am using, and I'll open that, and I'll say it's on index 9, which is the row. Then I'm going to say the row, I'll say 9, and the column is 5. So I'll specify column 5, col 5. And you see, I have it. That's it down. And that is how you do that. That is how you do that. Just like the way you have lock, another thing you can use for the same thing is at. You can use at for the same thing. So if I copy and paste this, and I just say at instead of lock, that is values at 9 and column 5. It's going to give me the same exact thing, and that's it. So now we've been able to select based on the specific value attached as the index of the row, and also of course the column name. But what if we want to select them by their position? By their position. Because sometimes the index number may be wrong. Maybe the index is scattered and you've not reset your index, and you want to select things by the position that they are in the list, or in the data frame rather. So how do you do that? So we call it selection by position. Here we call it selection by label. That's what you use lock for. But if you want to do selection by position, the position of specific values. So how do you do that? Now selection by label. Okay, it's a comment I want to make. I'll just say selection by label. Selection by label. And I'll say, yeah, put in my data frame. Okay, I'm not doing this now. Put in my data frame. So what is the first thing that I want to do? So if I want to select what are the values that are in the ninth position in my array, that is, I want to get all the values in the ninth position in my data frame. I'll show us the data frame again. So let's assume that I want to see all data set that we have here. All the data set that we have here. Those are the things I want to show. I want to see them. So I'm going to just simply say since the first thing of course is the row, so I'm just going to say number 9. I'm just going to say number 9. So what is in position 9? So 0, 1, 2, 3, 4. What is in position 9? But I will not just do it directly, of course. I need to use, instead of lock, I'm going to be using iLock. This will help me to select by position. So here I don't need to add a specific column name, even when I am ready to select by column. I don't need to select a specific column name. So let's say I want to check what is on 9. You can see in column 1 of 9, we have 4.0. In column 2, we have this date. In column 3, we have this. In column 4, we have this. In column 5, and that's it. That's how you select. If I want to select the one on 5, I'll just say 5, and that's it. But we can do more with this. We can do more with this with iLock. So I'll say pd.dataframe. Let me close this and say iLock, because I want to select by position. So let's say I want to select just the values in 3 to 5, in the 3 to 5th 5 positions, the 3rd to 5th positions rather, and I want to select just columns from 0 to 2. Columns for 0 to 2. So what am I trying to do here? Remember, the last value, when you have 2, it means it's going to show me values from 0 to 1. Here is going to show me values from 3 to 4, not 3 to 5. But you need to add like one value with the last value. You need to add 1 to it. You want to select up to 4, you add 5. You want to select up to 7, you add 8. So that is how it works. So here now you can see column 1 and 2. Those are the first 2 columns. That is 0 to 2 means 0, the first one, 1, the second one. Here 3 to 5 means what we have on 3 and what we have on 4 is not going to add what we have on 5 to it. And that is how it works. So that is how you can select by position. So you can see in this case now, there's no need to like add your column name and everything of that nature. So it's just pretty straightforward. So if I want to add like several rows to what I have, I could do more using this. So here now, if I want to add multiple rows, so all I just do is, instead of 3 to 5, I can pass in a list, and I can say, let's say I want to select the 1st, the 2nd, and the 4th, and I'm just going to say 1, 2, 4. So in this case, it is not going to give me 1, 2, and not give me 4. Why? Because here I am not doing it in terms of like from this point to this point. I am passing in specific position. So I'm going to get everything that I want. So another part is we can pass in a list. Let's say I want to get the first one and the third one. So that's going to be 0 and 2, because 0, 1, 2. So 0 is the first one and 2 is the third one. So it's going to give me just 0 and 2, not 0 to 2. So I pass in a list and say 0, and I pass 2, and that's it. So let's see. So you see 1, 2, and 4, then column 1 and column 3. That is what you can also do. So the last one on iLock for selection is, you can also do it in this form. Let's say that I want to select all the rows and I want to only have from column 1 to column 3. All the rows from column 1 to column 3. I'll just do this and just say all the rows. This, when I just put this column, it shows me like I want everything in the row. Then for column 1 to 3, I'll just say 1, 2, 3. All right, 1, 2, 3. That is going to give me only 1 and 2. It's not going to add 3 to this. And that's it. So that's it. So we have our column 2 is the number 1 in terms of position. That is, column 1 is 0, column 2 is 1, column 3 is 2. And that's it. That's how you do it. So Let me know in the comment section which one you prefer. Would you prefer to select your data using lock, or using at, or using ilock? Okay, where's the at? Using at or using ilock? And just like the way we used at, we can still use iat. So Pandas is so interesting. We can use iat to achieve the same thing we're achieving with ilock. So if I say iat, it's going to give me the same thing. Oh, iat isn't working for this. Iat isn't working for this. I was expecting iat to work, but it did not work. Okay, that's bad. I was expecting iat to work, but it did not work. But I've always preferred using ilock. For me, I prefer using ilock. Why do I prefer using ilock? It's because it's easier. I can just specify the position of what I want and bring it out without having to type like long column names. So sometimes you could have column names that are like weird in terms of the spelling on the way the data has been stored, and they could just probably take your time. So I prefer using the ilock instead, because I can select by position. All right, so now there's another thing in selecting data. I'll call them Boolean indexing. Boolean indexing. That is, I want to select my data set based on a specific condition. I want to select data set based on a specific condition, and only those, maybe the rows meeting that condition or the cell meeting that condition will come out. So if it is true for the data set, is going to, of course, bring it out from the data frame. Rather, if it is true for a specific value in the data frame, is going to bring it out, and if it is false, it's not going to bring it out. So we're going to see it. Let's do some practicals. Let's do some practicals here. Now I'll call it Boolean indexing. Boolean indexing. Boolean indexing. Or some people love to use it Boolean, but I think Boolean sounds nice to me. So I'll just say specify my data frame, and here what I want to do is I want to select where a specific condition equals true. So if you check my data set, again, the data frame, you will see that we have like cats over here, and we have up, down, up, down, up, down. So let's say I want to select only the situations where I have up and I don't want to see down. Only situations where I have up and I don't want to see down. So how do I do that? Now I can do this and say let's say the column where I have up is column 5, and say column 5 equals. So it is not just equals, because in Python sometimes when you use like equals, it is equals can mean an assignment of a variable. It's an assignment of a variable. So let's say I want to say d equals 5, something like this. So what I'm saying is that store 5 in d. Okay, so I'm assigning 5 to d as a variable. So that is why, but when we want to use like equals to set a condition, okay, we use double equals in this case. So that is how it is. To say this is not an assignment, here I am trying to carry out an operation. So let's say I want to say where it is equal to up, and I say enter. Now, do you see it gave me true, false, true, false, true, false, true, false. Now let's compare. Let's look at the data, and let's just select column 5 only. Column 5 only, and let's run it. Now you want to see that where the condition is true is the place where we have up. So when we have up, it comes back to true. When we have down, it returns false. True when it's up, down when it's false. So that is Boolean indexing. But what we really need to use is, we don't want to see true or false, true or false, true or false. So to do this, what we need to do is, now, if this condition is true, we now want to give it the data frame. Okay, we now want to give it the data frame where we are saying, okay, subset based on this condition. That is, everything that is true, give me the values that are true in this old data frame. I only want to see the value where this condition is true. And that is it. That is what I want to do. And let's say you use, sometimes if you use not equal to, you can see if you say not equal to up, it's going to ensure that all the places where you have up, they are going to be false. So you can see where we have up, it's false. And another part where you don't have up, it is true. And that's how we are subsetting this data. But here I want to say equals up. So how do I get the data? Now I need to wrap it with the data frame again, this way. So what I'm saying is that in this data frame, find me where this is true. That's it. In this old data frame, extract the values that meet this condition. That is how it works. So let's see. Now, do you see? It's giving me all the rows where this is true. So you see that I'm getting all the rows. That is the whole part of this data frame. I'm getting everything where this is true. And that is exactly how it works. That is exactly how it works. So that is how you select data based on like a specific condition. That's how you select based on a specific condition. Okay, so there are other things that we can do also when we are subsetting data. When we are subsetting data, we can also use different methods to subset data. There are methods where you want to check if we have like a specific word. Maybe you have different categories. So instead of using, let's say, equals this, you can use another, of course, method in Pandas that can help you to find a specific, how do I put it now, where you can find a specific value that you want. So, but before we do that, I'm going to show you, if I am working on with a data frame and I need to do something where I don't want the new changes I will be making to affect the data frame. I just want it to, the new changes I'm making to affect the. So here now, I want to copy the data set and say here, if I say df equals pd.dataframe, for example, I'm creating a new data frame out of the initial data frame we have. And I say df equals pd.dataframe. Now, even though I have df already, and all the changes I'm making them on df. Let's say I remove a colon, I do whatever I do to this data frame, it is still going to affect this data frame, this pd.dataframe. So I have not really like copied, if I would say it, I've just like reassigned it to df. So any changes I'm making to this df is still affecting this because it is still the same. But how do I do it where whatever changes I'm making to df will not affect the data frame, the initial data frame? All I just need to do is to use the method called copy, and that's it. And if I do that, it creates this entirely new. So whatever I do here is just a copy of this and not a change that is affecting this. And that's how you do it if you want to copy your data frame. So everything I'm going to be doing downwards now, after now, is only having an effect on this. And that is how it works. So I'm going to do everything I'm doing further. I'm going to be doing them on the df. Okay. Now, the other thing I want to use is I want to use what I call the isIn, the method called .isIn, to select my data. I want to use this method called isIn. Now let's do this. So Like I said, we have a specific data frame, and in the data frame, we want to select values that meet a specific condition. So I select my column. I'm saying column, which column are we working with? Have we been working with? We've been working with column 5. So I will say column 5. Then I'll pass it and say dot is in. Then I'll open a bracket. Within the bracket, now, because you within column 5, let's say you have more than, let's say you have 5 categories in column 5. Let's say you have 5 categories in column 5, and you want to select values like in the complete data frame belonging to specific categories. So if you want to do that here, for example, you will need to do it like by writing, this will be longer. You're going to do it longer here. So you're going to use like, let's say PD data frame column 5 equals up, and you want to like do another like within column 5 also, you want to set a condition that, let's say you have up, down, middle, top as category, and you want to select middle and top. Okay, or let's say you want to select up and middle. You will need to write another condition within this place. Like you're going to write another condition by using like and to how do I put it now, to bring everything together, but it's going to be long. That means you're going to write this whole thing this way. You're going to write it twice. You're going to write it twice, like putting them in their brackets, setting the condition, then I think joining them with the AND key. Okay, joining them with the AND key. Yeah, joining them with the AND key. So you're going to need to write this whole long thing. So let's say we have up and, okay, let me say wait. So let's say we have up and we want to select top. So we need to do something of this nature. But instead of going this mile, the dot is in function that we're going to be using, I'm going to clear this part. The dot is in function we're going to be using receives a list. You can only pass a list into it, because if I passed a single value, let's say I want down, and I say give me all the parts that are down, you see it's going to return error for me. So it's going to tell me type error. Only list-like objects are allowed to be passed to is in, and I passed just a string. So what it's saying is that this is set to default to receive a list. So even if I want to use one condition, that is things in that column that the rows where we have down, is I need to pass it into a list, and that's it. So it's going to show me all the parts that are down. If I want to select from multiple categories, let's say I want to select from top, but we don't have top in our data now, I will just pass down and top directly instead of writing those long one. So if I want to select like 4, meeting 4 conditions, I'm going to do those things 4 times. Like I'm going to have to write this and say and this condition and this condition and this condition. So far they are in the same column. I can just do what I want to do straight up in is in. And even if they're in different column, I only need to do it twice. Let's say I want things where we have cats. So I just need to do this and just wrap this together, wrap everything I have here, and do the same thing I was doing above. Copy this into 2, passing the new column into the other part and select it. So if you are working with multiple categories and you are selecting data from your data frame, I think this is better. So in the comment section, tell me which one you think is better for selecting data based on the condition. Is it is in, or just using it directly this way? The Boolean, I mean, they are both, of course, still condition. It's going to still give you like true, false, thereabout. So are you doing it this way or this way? Are you doing it that way or this way? Is in, or you want to do it directly? Let me know which one is okay for you, the one you love. Now let's move to the other one. So there are other conditions that we face when selecting data. Sometimes you have some data set where things are not very clean, things are not very organized, but you want to select all the rows containing specific words, just like the way we do like search in Google Chrome. You see, if I do search and I say WN, if I say WN, you can see it will look into whatever I'm doing and look for every part where I have WN. You can see every part where I have WN is going to look for it. So you can see that. We can also do this kind of thing with our data set, where we can say within a specific column, give me only the rows containing maybe this, not the full word, just these letters containing this. Show it to me. So like return it for me. So how do I do that? Just like the way we did this, let's say I still want to select the part that are down, but I only want to select based on WN. If I do it here, it's not going to work. You see, it's not going to return anything because there's none of the categories that I have that is just WN. But we can do that using another method. But in this case, it's going to be like a string method. So what we want to do now is our data frame first, and we are saying select the data based on, of course, this condition. So we select our colon and say colon 5. Then you say dot, you say str dot, then you say contain. That is, so long this row is containing this row belonging to this column is containing this word. It could be word, it could be a letter, maybe it's just W. I just want you to give me just, if it's containing this, return all the rows containing this specific thing. So you could have that. Maybe you are dealing with customer review data where you want to say, I want to select anywhere within a specific column where the customer used the word love, like I love the product, or where the customer says I hate the product. You just use the word hate in string.contain, and it's going to go through the data set and return just those reviews where the customer is saying, where the word love is in the data set. Okay, so string.contain, and I'll say WN, for example. I could even say W. So far it is in it, it's going to find it out for me. And I will run it and see what comes up. Okay, something is done wrong. Okay, now you can see I did this, is contains, not contain. So you can see it has no attribute called contain, so it is contain. So the data frame str.contains, that is str.contains this specific letter. Now you can see it still brought out the same thing. Isn't this amazing? This is also another way to subset your data if you want to find a specific word within a column. If you don't know the full word, or the data is not very clean and there's no way you can subset it with a full word within a specific cell in your data frame. Okay, now the next thing we'll be moving into is dealing with missing data. Dealing with missing data. Now, in dealing with missing data, we're going to use one of the things we said above about how to select data, which is iloc. And what are we doing? We want to select specific positions in our data. I want to assign a new value to them, a specific positions in our data. I want to assign a new value to them. So I will call this handling missing data. I'll say handling missing data. So we say let's insert NN to it. So remember how we use our iloc, our data frame, and we say iloc. We can pick by index. So what we are doing here now is we are saying within our data frame, within our data frame, remember we have the row and the column, and since we are selecting more than one row and more than one column, we need to use a list within it. So we are saying in row 1, row 3, row 5, and column belonging to 0, that is the first column, the third column, and the fourth column. You should assign none to it. This is the use of our numpy np.nan, np.nan. So I want to select like missing value to it. So if I run this now, let's check our data frame. So this is our new data frame. So you can see based on what we did, if you see none now, the first one we say in 1 and 0, that is in second row, first column, insert a none. The second one is that we say in the third row, in the second in the third row, which will be the, in this case, you can see we can say in 3, which is going to be the 0, 1, 2, 3 here in the first column. Over here, assign none to it. So we selected some random positions in our data to select to assign missing value, so we can deal with handling missing value. So this is our data frame. So what do we do in this case in handling missing value? The first thing you can do when handling missing value is, you can check, where do I have missing value in my data set? Where do I have missing values in my data set? Because sometimes I'm able to see all this because the data frame is not like very large. Okay, data set is not very large. We only have like 9, we have 10 rows, and we have 6 columns, so I can see everything. So what if you are dealing with like 1000 rows? So you can't see everything with your direct eyes. So what you do there is, let me check the data to know which one is not a number, of course. So you can say is NA, which ones are missing value. Then if I do this, it's going to tell me, it's going to be like a condition, and it's telling me, oh, this column false, that is this one is a number, the one where it is true, it is not a number, like that. But this doesn't help us so much to know which one. If you want to return the row, I think you can just subset it and say where we have not a number. I hope it works. Okay, you can see, of course, it's returning error in everything, like not a number. So you can't subset this directly. If you want to subset it, you will need to subset it using the method that we use, which is the iLock, and set a condition that where this is true, bring it out when there's NA. So, but how do you check which of your column have missing numbers? So you can say df dot is NA. Now you want to say dot any. And what is dot any telling you? Dot any is saying any column where we have missing values, return them as true, and those ones without missing value, return them as false. You see, in column 1 we have missing values, just like, okay, let's check column 1. You can see missing values. In column 2 we have no missing value. In column 3, missing value. Column 4, missing value. Column 5, no missing value. Column 6, no missing value. So that is how you check them. Now that you know that you have missing value, what can you do about it? What most people will do, especially if you are doing an analysis and you have large data set, you see, the actions you take on your data is not just, they are not random decisions. It depends on the uniqueness of the data set you're working with. So if you're working with finance data, you may not want to drop missing values, because if you drop it, it's going to drop the complete row where you have missing values. And it could be that the record of a finance is missing, and if you drop that, you're going to lose a lot of information. So, but if you are working with some data, with a kind of data set where you have large amount of data set and each value is not directly specific, it's not like a financial record where you need to miss something out. Maybe you take like an experimental data and you just want to ignore parts where you have missing values. You can just drop everywhere you have missing value directly. That's one way to undo missing value. Now, that's one way you undo missing value. So we can just say in the data frame, drop NA. Drop NA, and you say how equals any. How equals any. And this is it. So if I do this, let's see what it returns. Do you see? All the rows where we have missing value, they are all gone. So in 1, we have in row 1, we have missing value, they are all gone. In 3, gone. In 0 and 3, they are all gone. Those are the places where we have missing values. And we're only left with those parts where we have no missing value. So we only have 1, 0, 1, 3. In 5, yes, there are missing values, they are all gone. So we can verify. In 1, there's missing value. Let's see, you can see in 1, this whole row gone. 3, this whole row gone. 5, this whole row gone. So you can see that. And that is it. That is one way to do it, depending on the uniqueness of your data set. So your decision will be based on the objective of your data analysis or whatever you are trying to achieve with your data set. Okay, so bear it in mind. Another thing you can do to missing value, fundamentally, is to fill the missing value. So let's say you don't want to drop the data set and you're like, I want to fill all the missing values that I have with a specific number. So let's say you want to fill it with 3 or 0 or 2 or 4. That's another thing you can do. And to do that, it's very simple. All you just need to do is to use another method called df. The method is fill NA. That is, I want to fill every part where I'm having missing values. I want to fill it with 3, for example. So I say value is equal to 3. Fill NA, I say value is equal to 3, and I'll click on enter. Now do you see, everywhere we have it turns to 3. Where there's missing value, you can see everywhere you see 3 means there were missing values here. Now the interesting thing about when you fill NA is that if you don't specify like a specific data type or something, it's going to inherit the data type, the default data type of the column where you are passing it into. So you can see here it inherited the float directly. And that's it. So another thing you can do is fill NA. But look at something. Even though I've filled my data frame with fill NA, but if I check my data frame, I am still seeing not a number. Why? I've filled it with 3, but why am I still having the NaN? So what you need to do is, there are 2 ways to go about this. What you can do is you can say df equals to fill NA. And when I enter this and I check this, it's going to give me what I have here. It's going to store it into df again, of course. And I can use a different name. Maybe I want to have a new data frame, I can just use that. But the best thing that you can do, the easy way, is just to pass in another parameter into the fill NA. Just pass in another parameter and say in place and say equals true and enter. So when you do this, it's going to carry out the fill NA function, and at the same time it's going to save it. in place equals true. Now let's check our df, our data frame. Now do you see everything is filled? So everything is stored. Okay. Now that we've done that, another thing we're going to be doing in this part of this tutorial is we're going to be doing operation on multiple columns. So we're going to be doing some kind of operations on multiple columns. That's what we want to do. That's what we want to do. So here now, we want to do like, maybe I have multiple columns, of course, numeric columns, and I want to carry out, let's say I want to know the mean of a column, I want to know the sum of a column. Sometimes you may want to even know the standard deviation of a column, the mode of another column, anything you want to do. So one of the things you can do for that is you can use the aggregate function called df.dd. So here I'm going to say, let me call this operating on multiple columns. Let me just say operating on multiple columns. So I'll just say this is my data frame, and I'll use the agg function, like the aggregate function, and I'll pass in like a dictionary into it, key value PS. And what will be passed into my dictionary will be the colon will be the key, the colon where I want to carry out the action, and the how do I put it now? The action I want to carry out will be the colon, and not the action I want to carry out. Sorry about that. The colon I want to carry out the action would be the key, and the value is going to be the action I want to carry out. So in this case, I want to sum my column one, and I'll say sum. That is the action. And in my column 3, I want to get the average of my column 3. So I'll just say column 3 and say add it and call it main for the average. And let's see what happens. Now that didn't work. Oh, it said call do not exist. I need to add 1. So that's where the error is. So you need to check it. You can see that's how you debug your error. So you can see here now, I could see it, say df, something is wrong here. So I'm here now. It told me call is the problem, does not exist. So I check it again and I had the 1 to it because we don't have call in our data frame. So I run this. You can see for column 1, this is the sum of all the values we have. And for column 3, this is the mean of all the values that we have. Another way you can do it is you can do another thing on our column using user defined function. So let's say I have multiple columns and I want to carry out, let's say I want to get the square of every value that I have in a specific column. Let's say I want to get the square of every value that I have in a specific column. So I'm going to do, this is the data frame that I have. And with the data frame, I'm going to pass in a list of all the columns I want to carry out something on. So let's say in column 1 and column 4. Let's say I want to get the square of all the values that I have in that column, in column 1 and column 4. Now, what we're going to be using here is we're going to be using the transform function. And within the transform function, we're going to be using a user-defined function called lambda function. And what the lambda function, they are functions that are like used when you just want to carry out one specific task. You don't want to reuse a specific function. So instead of writing maybe a function for square, where I will now pass in my columns into it and like that, that's a long journey. So instead of doing that, I can easily use a lambda function since this is a task I am carrying out just once within my work. So I'll say dot transform, then I'll pass in a lambda function and say lambda, then x. Okay, x, what am I doing specifying with x is that I'm saying this x is my, okay, no, lambda, okay, and this x is these columns I'm passing into it. And what should you do? That is all the values, specific values in the columns I'm passing into it. That is the x. So what should happen to x? X, if you know basic Python, this is how you do square. That is x raised to power 2. So that is what you're doing. Like in basic Python, this star star, if I say 1 star, it's just going to multiply all the x by 2. When I say asterisk asterisk, okay, This is the best way. So it's going to square all the values. So let's see what our output will be. And that's it. You see, it squared every value that we have. So 16 is a square of 4. So we have 4 times 4, 3 times 3, 4 times 4, like that. Here we have 5 times 5, 3 times 3, 5 times 5, and like that. So that is what transform can do for you. Okay, now another thing we want to check out is what of the situation where I have, let's say, specific categories. So let's say you have a data set where you have different vehicles. I don't know so much about cars, and let's say you have Tesla, you have Ferrari, you have Toyota, you have Benz, like Mercedes-Benz, for example. Now, those 4, and you want to know within this data set, how many rows are Tesla? How many rows are Ferrari? How many rows are, how do I put it now? How many rows are Mercedes-Benz? Rows are Mercedes-Benz or something. Just to have an overview that, oh, in this data set, I have 50 Ferraris, I have 10 Tesla, I have this kind. So that is the idea. So that's what we want to do now. So the first thing you do is the column where you have, let's say, in form of cars, we can have it as car model. For example, we can say car model. So in our case now, we have one categorical column, and the categorical column is our column 5. So we select the column where we want to know the specific time they occur in the data set. So you're going to say in DF, for example, the DF, then we select column 5, and the function we use is say value counts. Value counts. So that's it. And when I do that, do you see the number of times where we have down, we have it 5 times. Then up, we have it 5 times. So that's it. So if it is in car type, it's going to just be that column where you have your car model. The value count is going to show you Ferrari, number, Tesla, the number, and like that. And that's just the idea. And that's it. So that is, those are the basics of Pandas that we've looked at, from value counts to transform, to aggregate, to filling NA, to imputing NAs, and everything that we've done all above. Now, the next thing we want to go into is how do we deal with working with, let's say, the data set you have is, you have data set from different places and you need to work on them together. So let's say the way data is stored in your organization is you have, let's say you have experimental data where you collected them separately. So let's say you have a specific plot, and in this month, in this specific plot, in plot A or plot C or like that, you collect data into this sheet, you collect data into this sheet, and you want to bring them together. Or the specific information about this plot, let's say you are collecting into a record, let's say it is in academia and you are doing an experiment, and you are collecting, let's say, soil information of a specific plot where you are doing your research. Let's say you have 10 plots, and in plot A, plot B, plot C, plot D, and you have soil information in one place. You collect them in one place, assign them to the specific plot, then you collect, let's say, the vegetation information in one place, you collect the crop yield measurement in one place, but everything still assigned to a specific plot. How do you merge everything together? How do you bring them together so that you can work on everything in just one data frame to organize your data set? That is what we are moving into. How do we do the joining of different data set together? Of course, when it is possible to use them together, because of course sometimes it doesn't make sense to join when it makes sense. So how do we go about that? That is the next thing we are moving into. So the first thing we are going to be doing is we're going to be using the concat. How do we concatenate? Now, what does concatenation do? What does concatenation do when you say you concat? Now, when you join, when you have left and right, normally when you're joining data set together, one is on the left, one is on the right, and you bring them together, it's going to put them beside each other. But when you use concat, one thing concat will do is concat is going to, instead of left and right, it's going to be up and down, where the first data frame is going to be up, then it's going to have the second data frame as the down. What situation will warrant using concatenation? Let's say you are collecting the same information about the same data set. They have the same column names, okay? And you want to concatenate them. That is, maybe you collect day 1 to day 50 in a different CSV, day 51 to day 100 in different CSV. Maybe you traveled and someone has collected the data for you, but it is still the same column names. And you want to merge everything together. You want to have them together in one data frame. In that scenario, since they are the same columns, you are going to be using concat. You're going to be concatenating them. If they have the same columns, you're going to be concatenating them. So it's just going to have what you had initially at the top and what you have next as the bottom. So that is how it works. So here now, I'm just going to be concatenating the same thing we have. So I will say pd.concat, and I'll open it and say, I'll pass it in. It's going to receive a list. So I want to concatenate my data frame that I have, and I want to concatenate the same data frame. That is, I want to have the same data frame in 2 steps. So one will be up and the other will be down. Now let's just do it directly. Let's do it directly and see what we have. Now look at this. Do you see? We have 0 to 9. It starts again from 0 to 9. Do you see? So it just brings everything we have and drops it down as bottom. So we have a df beneath, we have another one above. Okay, but when you do your concatenation, it is very important that you adjust your index so that instead of 0 to 9 and 0 to 9 is going to be like 0 to, since it is 20, it's going to be 0 to like 19. So how do you do that? You pass in another function called reset index. Reset index. And when you are resetting your index, and if I reset the index directly without doing something, let's do this. Now, do you see that it created a new column called index? So the former index became a column while it created a new index. It reset the index. So you now have 0 to 19, but you still have that index column as 0, 1, 2 to 9 and everything. And this could be awkward. So what we need to do is we need to remove this when we are creating. And the way to do that is within reset index, it receives a parameter called drop. And all you need to do is parameter called drop. It receives a boolean, true or false. So we're telling it is at default. When you don't pass in anything, it is false. That is, it is false. That is, don't drop the index. Add it as a new column. But when I say drop equals true, it's going to drop the column. So you see, everything is fresh now. So that is how you concatenate your data. I hope that is clear. Okay, if you are enjoying this video and you are learning something new, I would love you to, like, in the comment section, just put, oh, I learned this from this video, I learned this from this video, oh, I didn't know this before, I know this now. And if you know it and there's a better way to do it, you can also put in the comment section that, oh, you did this and it could be done better this way. Okay, and it will be really good because I am not just the only one reading the comment section. Others could read it and they can learn new things from whatever you are putting in the comment section. And when I read it also, I'll get new perspective to doing things and do it better and be able to serve my viewers with new knowledge that will really help them advance their lives in relation to data science. So thank you. Now moving on. After using concat, another one is we need to do joins. We need to do joins. And when we talk about joins, just like the way we have concatenation, we have it in up, down. In joins, we're going to have it in terms of left and right. Left and right. So there are two things that we do. There's joins, dot joins, and there's dot merge. So what are the conditions where we use dot join, and what are the conditions where we use dot merge? Those are the things I'll be pointing out in the next step. So let me call these joins. Joins. Let me call these joins. Now, what is the thing I want to do? So what I want to do is I want to create a new data frame. So I want to break my initial data frame into two, where I'm going to have a part containing column 1 to 3 and another part containing column 4 to column 6. So how do I do that? Very simple, like what we did before in selecting data. So I'll create a new data frame called df1, and in df1 I will say df.iloc. I told you I prefer iloc because I can select based on index, and that is really good based on the position. So I want to select everything in the rows, and I want to select only 0 to 3, that is select 0, 1 and 2 in df1. Then in df2 I'll say df2 equals df.iloc. I'll select everything in the row, then comma, then I will say 3 to 7. By 3 to 7 I mean the column 3, column 3, that will be from 3 to 7, that's going to be the fourth column. So it's going to be column 4, column 5 and column 6, of course ignoring the 7th one. What I now need to do is, for each of these data frame that I've created, I want to add another column to them. I want to add another column to them called ID. I want to add another column called ID. So within df1, let me pass in a new column called ID. So this is how you add a new column. Now to add a new column, there's a specific condition. So how do I want to add a new column? I'll use numpy.arange. All I just need is give me 10 values that are like sequential. So arange, that is from, it's going to be give me a value from 0 to 9, that is 10 values in the range of like 1 to 10 or 0 to 10 in relation to Python. So okay, before running that, now in df2, then I have ID also. I want to create the same thing in df2, and I say np.arange, and that's it, 10. So I'll run it. So if I check, let's check our df1 and df2 to be sure we have the right thing. So you can see this is df1, and that's, you can see column 1 to 3 with ID. Then df2 column 4 to 6. So we want to put them together where we're going to have it the way we had it before. Okay, that is what we are doing in the joins, where we use dot join and dot merge to put them together. Now the first action, let's do the join. Now when you say df1 dot join, and what am I joining it to? I'm joining it to df2. So I want to put them beside each other. So this is my left table and this is my right table, df2. So how do I want to join them? The inner join. So that is, usually the default. Now when I'm joining them, if there are tables that are replicates of each other in the data, I need to know the difference, like which one is from the second table. I want to know which one is from the second table. So in this case, we have ID in both columns. There's ID here and there's ID here. So I want to know which of them is the one for my second table or first table. The one for first table will remain with its name, and I can add like a right suffix to the one from the second table. So let me say I want to add a right suffix, and I will say let me call it, let's say second. I'll call it second, and I run my code. Now look at this. Do you see? So everything we had in the first table, then ID second, do you see? we had the same ID. So we've been able to join them together. But when we want to do those ones where we are saying join based on a specific column, so we are saying organize this data based on a specific column, and that is what we want to do in the next phase. So to do that, join can do that for us, where we specify the specific column where we are joining our data. What we need to do to use there is pd.merge. pd.merge. Okay, and in pd.merge, you can see we had our two data frames that were created, df1 and df2. So we say df1 and df2. Now we need to add one thing that's very paramount. We want you to join based on the ID. We want you to join based on the ID and not just based on any other thing. So we want everything that belongs to this ID to become rows that will be joined together with this specific ID. So that is the reason. So we have based on ID. So when we run it, you can see we only have one ID in it because we are joining based on ID. So we only retain just one ID because we are joining based on ID. So where will merge work? Sometimes, let's say you have a specific ID. Let's say you have a data frame where you have an ID. So someone can belong to a specific ID, but the person can also have another unique characteristic. Like, for example, dates, dates as an example. So let's say you have a transaction from a specific customer who has a customer ID, an ID. One ID, someone with an ID can have multiple transactions, which is on different dates. Okay. Now, you may want to join data set based on ID of the person and the dates of the transactions of the person. So that is the scenario where merge is very important. So if we have the ID and the date of transaction in a table, so let's say you have the ID, date of transaction in a table, but you don't have the amount of transaction, you don't have other information that could be in the other table. So you could have like ID, date of transaction, time of transaction in one table, and in the other table you have like specific amount, like who did they transfer the money to, okay, which bank, whatever information that is stored in a transaction list is in the other table, and you're trying to join them together. So if you use join on ID or use like the normal join, it's just going to look for commonality in it and join them together, and just join them together. Okay, even if there's no commonality between them, it just join them based on the role, organization, and everything. But when you use merge, you can specify, okay, join based on the ID, and because it is possible for that same person attached to that ID to have multiple transactions, we want everything to be aligned, and you can say join also based on date. So you have multiple conditions for joining. That is when you use merge. That is when you have to use merge. So that is the difference between join and merge. In join, you don't set the different columns you want to join on, but in merge, you can set different columns that you want to merge on, so that there's alignment in your data set. Okay, so that is how you use join. That is how you use join and merge. That is how you use join and merge. So what do you do next after knowing how to join, merge, concatenate? The next thing is you want to understand the grouping of your data. You want to understand the grouping of your data. So let's say I want to group my data based on everything belonging to a specific ID, and within that ID, I want everything belonging to everything in a specific column belonging to a specific ID. So let's say I want everything to be grouped by their ID, and whatever is belonging to column 3 you should sum them. Or I want to group based on the ID and my category colon and say do the sum or find the mean of the values belonging to this. So let's do that first. Now here, what we're going to be doing is using, of course, the same data set that we have, before, which is we have our df1, df2, but in this case, I'm just going to be using the df that I have before, okay, the df that I have before. And what I'm just going to be doing is saying df dot group by ID, but we won't be able to really see the difference. So I am thinking we should concatenate our data again and create a new data frame. Okay, let's concatenate our data and create a new data frame. So we can use our pd.concatenate data that we had before in the beginning. So we can use this, what we had here, where we concatenated our data. We can store it and use this as the data frame we want to use over here. Let's call it df4. Let's call it df4 equals to this. So df4, so you have df4. Okay, so in df4 we have all this. In the same way, I'm thinking of something so that this could be easy for us to get what we're going to be doing next on the grouping, so that we can have an ID. So since our df1 and df2, they have an ID, we could concatenate them, but that is not really going to make sense. So what we need to do is, let's have df3 over here. First, we say df3 equals the merge that we have on ID. That's df3. We study that way. So for us to have our df4, let's just concatenate df3 twice so that we have the ID in multiple places. Yeah. Okay, then we have df4. Okay, so you can see, so here now we have like values belonging to more than one ID. You can see, so we have ID 0 twice, we have ID 1 twice, we have 9 twice. So it's easy for us to have like multiple ID per within our data frame, and we could enlarge our data more. Okay, we can enlarge it more, but there's no need to do that now. So the next thing we want to do for our grouping, to be clear, now we have the data frame for the grouping. So we just see df4 dot group by, then we pass in what do we want to group it by. We want to group by ID. Now we've been able to group it by ID. Look at this. It's not going to return anything when I run it, but when I use the group by, there's something I need to group it by, right? So here now, there's something I need to group it by. So in column 3, I'm grouping by ID, but there's a column I need to show in the grouping. So here we have our column 3 as this. So what I want to do is every value belonging to a specific ID. So this is in column 3, 3.0 belongs to ID 1. And in ID 1 also, we have 3.0. So I want to sum every value belonging to a specific ID. So to do that, I'll just say column 3. And what do? I'll say dot sum. Then I run it. So in this case, you can see it's going to give me the sum of everything. So everything belonging to column 0, it sums it. Everything belonging to ID 1 rather, it sums it. I can even use mean. You see, I get the mean of everything. So that is how it is done. Another grouping that we can do is multiple grouping. multiple grouping. This is like single grouping. We are grouping based on one thing, but the next time we want to do the same thing, but we want to do it based on multiple grouping. So I'll copy the same thing that we have here and convert this to a list. Convert this to a list. Since I'm going to be adding multiple, then I will say colon 5, which is our categorical column. So in our categorical column, we have column 5. So we are saying everything, group it by ID and group it by column 5. That is, in ID 1, everything that is up that belongs to ID 1, you should do the sum of the column, the mean of the column 3. So let me use sum instead. Let me just say sum. Everything belonging to this ID and in this column for a specific category, give us the sum. So let's run it. So do you see? In 0, we have down. It is 0.0. That is, we don't have in ID 0. We have the down that we have in ID 0. There's nothing to sum, so it's 0. Then we have up within ID 0. So we have 4.0 as the sum of the value that we have there. And that is just the idea of grouping. This can be done for different purposes. You can use this for different purposes. Maybe you want to, maybe it's a population census and you want to sort by, I want to know the population of people who belong to a specific country and a specific state. Give me the sum of the people. Give me the mean of the people belonging to a specific country and a specific state. Or even they belong to a specific country, specific state, and they belong to a specific address. So everybody belonging to this location, give me the sum of the numbers of people that are found in this location. And that is how you do the grouping. That is how you do the grouping. So until end this tutorial, the last thing will be exporting and importing of data. Exporting and importing of data. So we have our DF4, that's our final data set that we want to export and import. So I am using Google Colab. I'm using Google Colab, and since it is in Google Colab, we need to do something. In Google Colab, you can store things in your Google Drive. That is the best way to store your data set. So it is not like I'm in my local drive in my laptop and I'm using my whatever I'm doing. So whatever things I'm storing or I'm importing, it is within my Google Drive. So the first thing you do within Google Colab is to export something into the drive or to import something into the drive. You need to mount your drive. So I'll call this exporting and importing data. So the first thing is to mount the drive. Mount drive. So there's nothing to mount over there. It's just a comment. So you just say from google.colab. That is how you do things in Google Colab. Import drive. That is the first thing. Then the next thing is, what do I want to mount in my drive? I want to mount my Google Drive. So you use it this way exactly. It's like a standard. Just say /content. That's like the directory within your Google Drive. And say /content and /drive. /content/drive. Then you run this code. Okay, this is not working. Okay, I said module object is not callable. Okay, I'm mounting my drive, so it's going to be drive.mount, and you click that. So it's going to ask me to connect to Google Drive, and you confirm what you're doing, and I click on allow. Yeah, and that's it. It's going to do its work. Mounting. So just wait a few seconds for it to mount. Okay, you can see mounted at content.drive. So that is how you do it. So whatever I'm doing now, importing, exporting, they're going to be storing into my Google Drive. Now, how do I export my data frame? Let's say you've worked on a specific data set and everything, and you want to a specific data set that you're working. And of course, in Pandas, you're working with the data set as a data frame. Now you want to export it. So what do you do in that scenario? So use another function in Pandas called to_CSV. So I say df4, you just say the data frame, you select the data frame, then you say .to_CSV, and you give it the title. What is the name of the file you are exporting to CSV? So you say final, I'm going to call it final df, say final data frame. That's what I'm going to call it, and I call it CSV. You must add the extension of the export since it's CSV. Now, if I do the direct export this way, let me do the direct export, and you're going to see something. So my file has been exported. So to verify, we'll try to import the file back to Pandas. Using Pandas, we import it back to our workspace. So to do that, I'm just going to say final. Let me create a new data frame where I'm going to be exporting it and importing into. So to import your CSV, you say pd.read_CSV. While exporting, you say to CSV. While importing, you say read_CSV. Then you do this and you just put the exact file name into it. So I don't need to add any other directory since I am working within the same directory in my Google Drive. So, and I load it and check it out and say final df. If you notice, this is my data frame. Let me check df4 so that you can see the difference in what I'm saying. So you can see df4. Now, if you look at df4, you will see that there's no colon like unnamed in it. And where this problem is from is that while exporting my data, I did not drop the index. I'm supposed to drop the index. Else, in the data frame to be exported, it's going to add the index. It's going to add the index as a column. It's going to add this as a column, and that is, that is not what you want. So to do that, all you just need to do is into CSV, you specify another parameter called index, and it is simply, since the default is true, that is export index with it, but now we need to change that condition into false. We need to change the condition into false. That is the next thing that we need to do. Okay, and that's it. So we're changing it to false, and I'll run it. You can see it's been exported already, and final df. Now I'm reading it back. Now you see, if I read it now, there won't be an extra colon. You see that? Clean. So that is the best way to export. You drop the index, except there's a condition where you have to use the index for something. There's no need for you to add it, so it is better you drop the index by specifying this parameter called index.false. So index equals false rather. So that is the that brings us to the end of the part 1 of this introduction to Pandas. I believe you've learned something. If you've learned something, you can comment that you learned something, and if there's an idea that you think I should have touched at the basic level that I've not spoken about, you can put it in the comment section, and I'll factor that in when I'll be putting up the part 2 of this video. In the part 2, we're going to be working with a real life data set where we're going to be manipulating the data, or we'll do what we call the data wrangling, to wrangle the data, to try to add new column based on the condition, filter data, sort data, and do the things we spoke about basically on a real data set, and answer questions from the data, because that is really what you do as a data analyst. You are trying to answer questions from the data. So watch out for the second part next week. Thank you very much for waiting through the video. Please remember to like and subscribe. So that's it today on Learn with Meshach YouTube channel. See you in another video. Thank you.